At this point, we've uploaded our images and then we've annotated said images. Now what we want to do is within Roboflow, we'd like to organize our images. Organizing our images often takes one of two forms. The first form is going to be pre-processing our images. The second is augmenting our images. So let's go over to the Roboflow dashboard and see how it's done. When you're in your Roboflow dataset, what you will want to do is go ahead after annotating your images, click Dataset here. Once you click Dataset, it will show you the name of your dataset. It will also show you all of the different summary statistics that you may be interested in here. For example, in your source images, how many images you had in your dataset. Then moving on to train test split, how did you split your data up upon upload? You're going to be able to see a lot of this information here. Before getting into pre-processing and augmenting though, there's one thing that I do want to note. This term generating new version may be a little bit unfamiliar to you. Within Roboflow, you've uploaded a lot of source images to Roboflow. What we want to do now is we want to be able to generate a version of that data set. So we're going to take those source images and we may, when we apply pre-processing and augmenting to that data set, make some fundamental changes or tweaks. You might be happy with some of those changes, and then maybe after the fact, you don't like some of those changes, so you want to undo those. So it's important to know what generating a new version is. When you upload those source images are frozen. They stay there as is. So when you apply pre-processing and augmenting to your dataset, the source images don't actually change. Instead, you're going to pick and choose what pre-processing and augmenting steps you want done to your dataset, and then you will generate a new version of that dataset. What that means is we're going to create almost like a copy of the source images with pre-processing and augmenting applied. What that does is it serves as a snapshot in time of what that pre-processed and augmented data set looks like. And you can go back and take a look at that whenever you want. And your source images are never changed, so that if a mistake is made, or if you just want to go back to your source images for really any reason, you can still do that. So with that said, we want to be able to generate a new version of these images. So I'm going to go ahead and click pre-processing. Pre-processing, these transformations that you decide on here are going to be applied to the entire data set, everything that's in the training data, in the validation data, and in the testing data. There are two pre-processing options that are applied by default here. The first is auto orient. If I click on auto orient, this will describe what auto orient is doing, and we'll have a link in here to a blog post that you can check out if you want more information on when or why you might want to auto orient. Here, the short answer is that you almost always want to auto orient your data, and so I'm going to keep that as the default. It's one of the reasons why we apply it as a default. The next thing here is resize. So perhaps you want to resize your images. So if I take this image, let's say that I wanted to stretch it to 600 by 600. You could resize it. Or if you wanted to resize it to 600 by 800, you could do that. And you can see what the original image as well as the resized image will look like. Again, in this case, I'm going to keep the default of 416 by 416. The smaller the numbers are here, the faster your model will train. However, the smaller your numbers are here, the less information or the fewer pixels we're giving to the model. So we want to be judicious in terms of what we do. I'm going to stick with the default, and then if my model doesn't perform well, maybe I'll come back and generate a new version of the data set with the resize option selected, but maybe resize to larger images. Again, there's some guidance that's provided here with this and most of the pre-processing and augmentation options that you might select that weigh in on when and why you might want to do this thing. You can add other pre-processing steps as well. For example, if you want to convert all of your images to grayscale, There's some that are behind Roboflow Pro, for example, tiling your images, which works well when you're trying to detect really small objects. I'm not going to go into any of those here. I'm going to stick with the defaults for pre-processing my images here. Next, let's move into augmentation. Now, augmentation is similar to pre-processing in that you're applying transformations to your data set. However, it's different because while pre-processing is applied to your training and your validation and your testing data set, augmentation techniques are only applied to your training data. Now, you might be saying, why is that the case? Well, I'll tell you. When we are working with our data set, I like to think of pre-processing as standardizing or preparing our images. So we might convert everything to grayscale to help our model fit faster. We might resize our images because if we're taking pictures with different cameras, those images might be of different sizes. So we want to make sure they're all of the same exact size and shape when we're passing them into our trained model. That has to be true not only of the images that we're training on, but also our validation and our testing images. When it comes to the way that we're thinking about computer vision though, whenever you're passing information into, in this case, images into a model, there are going to be some downsides to that. For example, camera placement is very, very important. What happens if I were to take a camera, if I think about this webcam, and I wanted this webcam to be able to detect me creating American Sign Language letters with my hand. Note, I'm not an American Sign Language expert, to be very clear. But with that, let's say that I were to create the letter C, and I put C very, very close or very, very far from the webcam. Well, these are things that we might want our model to be able to better understand, that a C is a C is a C, whether it's close, whether it's far, whether it might be a little bit off the edge of the frame, whether it might be rotated a bit. We might want our computer to be able to pick up on that. Because of that, we want our trained model to be able to look at many, many, many different options of images, not just the ones you created, but maybe these tweaked or these augmented images. That's the purpose of augmentation. Now you might be saying, okay, Matt, we want to be able to create these different copies, but why would we not also apply that to the validation and the testing set? The answer to that is simple. When I'm validating my model's performance and I'm testing my model's performance, I want the validation and the testing sets to be on the true blue data that my model might see in the real world. We don't want synthetic data wrapped up in the validation and the testing set, because when we do create those additional images and put them in the validation and the testing data set, that might artificially increase our model's performance and make us feel more confident in our model. So augmentation options are only applied to the training data set. With all of that said, let's actually get into augmenting our data here. So we want to create new training examples for our models to learn from. If I click Add Augmentation step here, you'll notice that there are many different types of augmentations that I can select. So for example, one of the things that I mentioned was if I had created a C with my hand, moved it closer or farther away, we can simulate that with the crop augmentation. So notice here up top, this is the original image with 0% cropped. On bottom, this is the exact same copy of that image with 20% of it cropped. You can see that as I take this slider and I move it, it changes the positioning of the image or the positioning of the camera artificially. What I'm going to do here is I'm going to set this to be 30%. I'll click apply. 30% is chosen somewhat randomly. That's why we generate these versions. Maybe if 30% doesn't work well, I might increase or decrease that number. I'm going to go ahead and add a couple more augmentations. Let's go ahead and look at rotation. Rotation here is going to, as it mentions, allow your model to be more resilient to camera roll or how much your camera may rotate. So here, for example, I have a C that I've created with my hand. This is an American Sign Language C. This, I assume, is also a C, or this is a C as well. So rotating that a little bit doesn't fundamentally change that the letter here is a C. Now, you could rotate this pretty significantly. I'm not going to rotate it that significantly. I'm going to put this to plus and negative 20 degrees. So we've got, again, the original image, and we've got this rotated positive 20 degrees and negative 20 degrees. We're going to randomly create images that have some random rotation in it, and I'll talk about what that means in a moment. The last augmentation step I'm going to add here is I'll add a little bit of noise. Notice that noise here, we're adding a little bit of, it's almost like pepper to our image. So if there was rain or if there was static or something like that, we're able to help our model be more resilient to when that comes up. I'll keep this at 5% and I'll click apply. Now you can go through and add way more augmentation steps if you would like, but I'm going to go ahead and click continue. At this point, we're finally ready to generate this version of our data. So we're going to, in this case, generate 1,450 images because I'm going to do a maximum of 3 copies per image in our training data. You can see how 1450 is calculated here. We had 423 images in the training data, and we're going to multiply that by 3 variants. When we use the term variance here, that means that we're taking each image and we're creating 3 augmented versions of that image, or artificial versions of that image, each with a random amount of crop, a random amount of rotate, and a random amount of noise based on the parameters that we selected in the last step. So we've got our 423 training images, and we're generating 3 augmented versions per each of those images. Plus, we have 121 images in our validation data set. Plus, we have 60 testing images, which means we should have a maximum of 1,450 images in that final output here. There might be a couple of reasons that it's not quite 1,450. If you happen to get duplicate images in here, we deduplicate those images. And we've got the filter null pre-processing step that may remove some images from the output if there are null images in there. I'm then going to go ahead and click generate. So this is initializing and downloading, and you can see that progress bar. I'm going to instead rename this version 1 or V1 and save the name. So the data set that I'm generating, I'm calling it V1. You can make it a bit more descriptive if you want based on the pre-processing options that you chose. Once these images are all processed, as we are here, you'll now see that we have 1,450 images. And if you look at some of these images, for example, this one, you'll notice that a lot of noise has been applied to this image. And you can scroll through here and see some noise as well as some of that random rotate. It's hard to detect crop in here, but these images have been cropped a bit as well. So that is organizing our images. Organizing our images is going to be taking those images that we've already uploaded and annotated, and then we're going to take those images and apply pre-processing and augmenting to them. And the final thing that has to be done there is to generate the version of that data set. Now that we've done that, we're next going to move into training our model, which we're going to touch on in our next video.